Recently, very important news were published about Hubble telescope and a lot of news. The first news with us says, Hubble hunts visible light sources of X-rays. This Hubble Space Telescope image features the dwarf galaxy HighSea 776. This swirling collection of new and old stars is located in the constellation Virgo in the Virgo galaxy cluster 100 million light-years from Earth. Although HighSea 776 is a dwarf galaxy, it's also classified as a S8b type or weakly barred spiral. This highly detailed Hubble view demonstrates that complexity. HighSea 776 has a ragged, disturbed disk that appears to spiral around the core with arcs of star-forming regions. The image is from an observation program dedicated to the study of dwarf galaxies in the Virgo cluster that is searching for the visible light emissions from sources of X-rays in these galaxies. X-rays are often emitted by accretion disks, where material that is drawn into a compact object by gravity crashes together and forms a hot, glowing disk. The compact object can be a white dwarf or neutron star in a binary pair that is stealing material from its companion star, or it can be the supermassive black hole at the heart of a galaxy devouring material around it. Dwarf galaxies like HighSea 776, traveling through the Virgo cluster, experience pressure from intergalactic gas that is similar to the pressure you feel from air hitting your face when you ride a bicycle. This intergalactic gas pressure can both stimulate star formation and feed the central black hole in a galaxy. As more material swirls down toward the black hole, it creates an energetic accretion disk hot enough to emit X-rays. While Hubble is not able to see X-rays, it can coordinate with X-ray telescopes, such as NASA's Chandra X-ray Observatory, revealing the sources of this radiation in high resolution using visible light. Dwarf galaxies are very important to our understanding of cosmology and the evolution of galaxies. As with many areas of astronomy, the ability to examine these galaxies across the electromagnetic spectrum is critical to their study. The second news with us says, former NASA Center Director scientists to receive presidential medals. President Joe Biden will present Dr. Ellen Ochoa, former Center Director and astronaut at the agency's Johnson Space Center in Houston, and Dr. Jane Rigby, Senior Project Scientist for NASA's James Webb Space Telescope, each with the Presidential Medal of Freedom Friday in a ceremony at the White House in Washington. The Presidential Medal of Freedom is the nation's highest civilian honor award, and these two NASA recipients are among the 19 awardees announced May 3. Cho is recognized for her leadership at NASA Johnson and as the first Hispanic woman in space, and Rigby is recognized for her work on leading NASA's Transformational Space Telescope. NASA Administrator Bill Nelson said, "I am proud Ellen and Jane are recognized for their incredible roles in NASA missions, for sharing the power of science with humanity, and inspiring the Artemis generation to look to the stars." Among her many accomplishments, as a veteran astronaut and leader, Ellen served as the second female director of Johnson, flew in space 4 times, and logged nearly 1,000 hours in orbit.
Jane is one of the many wizards at NASA who work every day to make the impossible possible. The James Webb Space Telescope represents the very best of scientific discovery that will continue to unfold the secrets of our universe. We appreciate Ellen and Jane for their service to NASA and our country. The next news with us says, researchers develop founding document on synthetic cell development. Cells are the fundamental units of life, forming the variety of all living things on Earth as individual cells and multicellular organisms. To better understand how cells perform the essential functions of life, scientists have begun developing synthetic cells, non-living bits of cellular biochemistry wrapped in a membrane that mimic specific biological processes. The development of synthetic cells could one day hold the answers to developing new ways to fight disease, supporting long-duration human spaceflight, and better understanding the origins of life on Earth. Researchers outline the potential opportunities that synthetic cell development could unlock and what challenges lie ahead in this groundbreaking research. They also present a roadmap to inspire and guide innovation in this intriguing field. Lynn Rothschild, the lead author of the paper and an astrobiologist at NASA's Ames Research Center in California's Silicon Valley, said, "The potential for this field is incredible. It's a privilege to have led this group in forming what we envision will be a founding document, a resource that will spur this field on. Synthetic cell development could have wide-ranging benefits to humanity. Analyzing the intricacies that go into building a cell could guide researchers to better understand how cells first evolved or open the door to creating new forms of life more capable of withstanding harsh environments like radiation or freezing temperatures." These innovations could also lead to advancements in food and medical sciences, creating efficiencies in food production, detecting contaminants in manufacturing, or developing novel cellular functions that act as new therapies for chronic diseases and even synthetic organ transplantation. Building synthetic cells could also answer some of NASA's biggest questions about the possibility of life beyond Earth. Rothschild said the challenge of creating synthetic cells informs whether we're alone in the universe. We're starting to develop the skills to not just create synthetic analogs of life as it may have happened on Earth, but to consider pathways to life that could form on other planets. As research continues on synthetic cell development, Rothschild sees opportunities where it could expand our understanding of the complexities of natural life. Life is an amazing thing. We use the capabilities of cells all the time. We build houses with wood, we use leather in our shoes, we breathe oxygen. Life has amazing precision, and if you can harness it, it's unbelievable what we could accomplish. The next news with us says, Earth planning. Wednesday, May 1, 2024, the planning was a little out of the ordinary. Not in terms of the plan itself. Curiosity's team built an exciting plan utilizing much of its science toolkit. Scott Van Bommel, planetary scientist at Washington University, said, "The plan was unusual rather due to my role as APXS-PUDL reverse shadow. While I normally staff the APXS-PUDL role, the person on shift responsible for APXS downlink assessment and uplink planning, operating as a reverse shadow, meant I took a backseat to another APXS team member who was completing the final phases of their training for the role. They handled their duties with great aplomb, leaving me to reflect on my first few shifts in the same role. As I'm typing this, given how long it has been since that time, I can't shake the comedy of narrating this section of the blog in the distinct and rapid-paced tone of 1940s or 1950s radio and TV. It was around a month after landing, September 10, 2012, to be specific. I was on shift for the first time as APXS and was not expecting much in the way of workload given the notional plan. Curiosity, on the other hand, had a different idea. As event logs of the Sol prior were received, the intended plan was scrapped and there was an opportunity to propose an activity. My mentor at the time encouraged my input. We were conducting operations at JPL then and walked down the hall to present our request to other members of the team before the Sol's uplink planning meetings officially kicked off. The proposal was accepted, and the proposed activity ultimately went according to plan. I can remember driving back to my hotel as the sun was coming up. It was then that it hit me. I had just influenced something that happened on another planet. It was a very surreal experience. What I didn't realize then, however, was how important these data acquired on my first shift as lead APXS PUDL would be, given they now serve as a baseline from which we assess APXS performance versus temperature over time. Today's APXS PUDL had a more typical experience. There are two APXS targets in the plan, Emerald Peak and Franklin Lakes. These targets are both on the same block, with Emerald Peak targeting the visibly altered rim near the lower portion of the block and Franklin Lakes more centrally located. Molly will acquire images of both of these targets, including a 3-position rotational stereo set on Emerald Peak. The last news with us says, HighSea rocket experiment achieves never-before-seen look at solar flares. After months of preparation and years since its last flight, the upgraded high-resolution coronal imager flare mission, HighSea Flare, for short, took to the skies for a never-before-seen view of a solar flare. Sabrina Savage, principal investigator at Marshall for HighSea Flare, said, "This is a pioneering campaign, launching sounding rockets to observe the sun to test new technologies optimized for flare observations has not even been an option until now. It was the third iteration of the HighSea instrument to take flight, but its first flight with ride-along instruments, including the Kool-Aid, Capri Sun, and Swift Solar Activity X-ray imager." Following a month of payload integration and testing in White Sands, New Mexico, investigators completed final launch site integration at the Poker Flat Research Range in Alaska. Each morning of the 2-week launch campaign window, the team spent about 5 hours preparing the experiment for launch, followed by up to 4 hours of monitoring solar data for a flare that registers as C5 class or higher with duration longer than the rocket flight. The launch finally occurred on the penultimate day of the campaign window. Savage said the sun was unusually quiet throughout the campaign despite numerous active regions. Both teams were getting nervous that we would not launch, but we finally got a nice long-duration M-class flare right before the window closed. The HighSea Flare mission launched at 2:14 p.m., just 1 minute after the Focusing Optics X-ray Solar Imager mission led by the University of Minnesota. Once in air, sensors on the HighSea Flare rocket pointed cameras toward the sun and stabilized instrumentation. Then, a shutter door opened to allow the cameras to gather about 5 minutes of data before the door closed and the rocket fell back to Earth. The rocket landed in the Alaskan tundra, where it remained until conditions were safe enough for the team to retrieve it and begin processing the collected data. For launches into the tundra, we have to wait a few days for the instrument to get back to us and then to be dried out enough to turn on. It was an anxious few days, but the data are beautiful and were worth the wait. Investigators weren't just testing new technology either. They also used a new algorithm to predict the behavior of a solar flare, allowing them to launch the rocket at the ideal time. Genevieve Vigil, technical and camera lead for HighSea 3 and Cool Aid at Marshall said, "To catch a flare in action is really hard, because you can't predict them. We had to wait around for a solar flare to start going, then launch as it's happening. No one has tried to do that before." Thank you very much for watching. Goodbye.